Hey there, it's Vicky and Nigel Henbest here on our first Pop Up Astro live. On Friday nights, I host Pop Astro Live, which is quite a formal show. We have guests organised and all sorts going on, and it's scheduled. But I'm basically in Wales at the minute, and we have got full lockdown here. And Robin and the crew at the SPA have kindly agreed to let me broadcast whenever I want. So that's fantastic because it means I can stay in touch with my favourite people, do astronomy vlogging, which is my absolute favourite thing to do, and connect with the wonderful members and maybe not so members of the SPA. So, Nigel, how are you doing?
I'm doing just fine, thanks, Vicky. Yeah, it's good to be chatting to you just out of the blue like this. Because there's so much up there in the sky to talk about. There's always something we can just latch onto and and have fun chatting about.
Great, Nigel. So tell us whereabouts you are this evening then.
Oh, I'm at home, which is in the leafy Chiltern Hills, in the corner of my house with a few old astronomy. No, wrong one. That's a Giotto spacecraft that went to Halley's Comet in 1986. I mean, I will say not the original Giotto because that's somewhere way out there in space now, but that's a model made by British Aerospace, who are the British contractor who actually built the main part of the spacecraft, although it was a European mission. And it sent back the first close-up pictures of a comet's nucleus, which was absolutely wow. And then the rest of these are a bit older astronomy books going back 100, 200 years maybe.
Oh, wow. Can you hold up, Mr. Giotto? Can you hold up Giotto, please?
Of course. There we go.
Oh, do you know, I've been thinking that was a cardboard cutout, but actually you could definitely hurt somebody with that.
You could, like my toe if I dropped it by mistake. So what we've got the, get this right way around. So that's clearly the antenna which sent the signals back to Earth. And the reason it's cylindrical is because to stabilize it's spun around, so it's not like a loft spacecraft which just sort of sit pretty and keep the same orientation as they move along. And this is like a gyroscope, so it's spun around its axis. So as it spun around, the antenna was spun in the opposite direction, so it always pointed towards the Earth, even though Giotto was spinning the other way. And then it had the camera. This white thing here was the camera. So it was coming into the comet this way. So the camera took the pictures as it was looking ahead, and this device here is a meteoroid shield. So I mean, a comet's got loads of dust coming out of it. That head of a comet is all gas and dust coming off from that solid nucleus at the center. So they knew Giotto was going to hit a lot of dust on its way in. So the idea of this shield was a dust particle would hit the front part of the shield and then just vaporize. And if I hold this right, you can see there's a gap between the shield and the main spacecraft behind. So the meteoroids would come in and they would impact there and they would blow into smithereens and gas and wouldn't actually hit the main spacecraft behind it. So that was protected, and that's how it took its pictures. And it's got all other kinds of instruments for measuring the properties of the plasma, the hot gas, and what it was made of as well. So that was our little spacecraft. And it's sad to say that when it went past the comet, the dust particles, of course, hit the telescope. Is actually a reflection telescope, but of course they damaged the mirror because there's so much dust. So we've got those wonderful close-up pictures. And although Giotto went on to see another comet afterwards, so Comet Grigg-Skellerup, Giotto was in fine shape, but the camera wasn't. So we didn't get any pictures of Grigg-Skellerup, but we did get the pictures of Halley. So that was a lovely little spacecraft.
Oh, I didn't realize Giotto was so cool. It was just probably, I can't remember how old I was when it did that.
You weren't even born yet.
Yeah, when did it launch actually?
85.
Oh, I was definitely not born then. I was born 10 years after that.
That's why you don't remember it, Vicky. I'll forgive you.
Oh, thank you. Right, Nigel, before we crack on, I've got something here. Now, I've been waiting 3 years for this. I mean, you've got to wait for Halley's Comet longer than this, but I've been waiting 3 years to have one of these in my life. Do you know what that is?
It looks like a twirl bar.
It's an orange twirl. Have you seen these, Nigel?
No, I'm not a big expert on twirl bars. I will admit, Vicky, one of my weaknesses in life is not knowing about candy bars.
Well, one of my weaknesses is knowing about candy bars, Nigel. So I'm just let me fiddle with the heater down it. Right. Twirl bars are my favourite chocolate, and chocolate orange is my favourite chocolate. And these have been on and off the shelves in selected locations for years now, and I've never managed to find one. So I'm going to test it live on air, first of all.
Hey.
I'm going to connect it with astronomy by saying sometimes astronomers need high calorie snacks to fuel them through the night.
Well, I remember that. Okay?
Oh, oh my God, it smells so orangey. And also in the Plug the Mug this evening, instead of the usual musty old water, I've got full cream milk tonight. So that is a nice combination, isn't it? Right, here we go. Well, it smells of chocolate orange, so that's a great start. 43 grams of orange milk flavored chocolate fingers. Oh, Nigel, I'm going to let you talk about the moon discovery while
you just enjoy yourself, aren't you?
When it gets on your feelings. Yeah. Do you know what? I'm going to eat that. You're going to talk about NASA's moon announcement, if that's all right.
This is for 1 minute without hesitating, deviating, or repeating myself.
No, 10 minutes. Right, off we go.
So the Lunar Challenge. Well, today NASA has announced the discovery of water on the moon, which is totally amazing, apart from the fact it's been discovered before. Well, obviously, it's interesting. The moon doesn't have any air. We know it's smaller than the Earth. It's blasted by sunlight. It has no atmosphere, so it can't keep the heat in. And more importantly than that, if you had any liquid on the water on the moon, the temperatures get so hot during the day that it would boil away. And because there's no atmosphere, there's no atmospheric pressure to keep it in. So even if you had water on the moon in room temperature, it would boil away just as when you go to the top of Mount Everest. And the pressure goes down, then your kettle boils at lower and lower temperatures. And the top of Mount Everest, you can't even brew a proper cup of tea, if that's what you should choose to do when you go to the top of Mount Everest. I mean, you might want to plant a flag or take some selfies. So anywhere on the moon, the pressure is so low, water would just boil away. And that's a problem to go there. I mean, when the Apollo astronauts landed on the moon, they took all their water and their food and everything with them. But if we want to go back there and stay and build a lunar base, then we've got to, carrying water from the Earth. Water is heavy stuff and it's a long way to go. And you need water, obviously for humans, you need to drink water and wash. The other thing about water, if you can get it, is you can break it up into hydrogen and oxygen, H2O, and then you can use those as rocket fuel, just like the space shuttle used to fly with that big tank of hydrogen and oxygen. You combine them and they burn and they power your rocket. So water is a good stuff to have. So the announcement today is about water on the moon. And you might say, Vicky, if you're probably too busy chewing a chocolate bar to say anything at all, but you might say, isn't this a sense of, see, I thought that might be the case. No, you don't have to say, I'll say it for you. You can go back to me again now. Okay. So you might say, isn't this just deja vu? Surely we've been hearing about water on the moon for quite a long time now. And the answer is yes. So although the moon can't have liquid water, the idea is that maybe it's there in some solid form. And up until now, the best bet has been ice. Well, ice is obviously just frozen water, we know that. And on the moon, where the sun doesn't shine, the temperature goes down way, way below freezing. So water can exist in ice form. Now, if that's near the equator, that's fine at night. But when the sun rises, the water will obviously, what we call sublime. It won't even melt and boil. It'll go straight from solid ice into water vapor and just dissipate. But near the poles of the moon, you have deep craters. And at the bottom of those craters, the sun never shines there. So it's a cold trap, as we call it. Any water vapor that gets in there can freeze into ice. And it'll stay there literally for thousands, millions of years, maybe even billions of years. And even if the moon never had any water to begin with, then you have comets impacting it. Now, I was talking just a moment ago about Halley's Comet, and one thing that Giotto found was that, as we suspected, comets are made largely of ice. Giotto saw the plumes of water shooting off from the nucleus of Halley's Comet, and it actually measured them with its instruments. So comets are mainly made of ice. We call them dirty snowballs. So comets hitting the moon will release ice, and some of that vapor from the collision could then get trapped at the lunar craters. And NASA's planned return to the moon, which we can talk about a bit later, manned expeditions, but I'll stick with the water for the moment, is planned to go to the south pole of the moon, because there's a deep crater there, a deep, large crater called Shackleton. Now, that's named after Ernest Shackleton, the great polar explorer, British polar explorer who went down to Antarctica, never actually made it to the pole, but his ship got trapped. And there's a lovely long adventure story there of how, after over a year stuck down in the ice, he managed to get his men back to safety. So crater Shackleton, we know from measurements from space probes going over it, unmanned ones, is likely to have water ice on the bottom of it. But to get to that part of the moon is quite difficult, to get to the poles. And also, it's in the dark. You've got to go down there, either yourself or your robots, into this incredibly cold place to get the water out of it. And what the announcement today was about, just to get back to what you first asked me, I told you I'd get there eventually, was this evidence that there is actually water in what we call mid-latitudes. So roughly the same, think of the United Kingdom being not at the pole, but not at the equator, similar sort of latitude on the moon. And the observation was made by a flying observatory, a 747 jumbo jet, which NASA has kitted out. Well, first of all, they had to cut a big hole in the side of it. And then they put in a big telescope, and it flies up in the top part of the Earth's atmosphere. And the advantage of that is you're above the water vapor in the Earth's atmosphere. So if you measure water vapor with your instrument, it's not just on your doorstep. It's coming from whatever object you're looking out there in space. So they found the signature of water on the moon. And in fact, in particular, a crater called Clangese, one of the largest craters on the moon. And anybody here, I'm sure many of people watching know all the lunar craters much better than I do. I can recognize Clangese. It's a huge crater, and it's got a string of little craters inside it, one of the oldest large craters on the moon, in fact. And this is where the water's been found. But it's it can't be liquid water, and it can't even be ice because the sun shines too hot there during the lunar day. So their best guess is that it's inside tiny glass beads. Now, we know there are glass beads on the moon because the Apollo astronauts brought some back. So the idea is you have a tiny, tiny bead of glass, and inside that is trapped some water, and that's what we're measuring. And that means you don't have to go to the lunar pole and go down into the really cold, dark insides of craters. You could go somewhere like Clangese, where you could be in full sunshine, and you've got the advantage of having solar power and being able to see what you're doing, being quite warm during the daytime, but you could actually get the water out of the soil under your feet. And that's why people are so excited about it.
Oh, wow, Nigel, that is amazing.
So, this is... as I say, the problem with it is, though, Ricky, I've been thinking about this. So you've got a glass bead and it's trapping the water inside. So however hot it gets, the water doesn't just evaporate. So that's a bit like, having this. This is a glass bead, which I just happen to take out of my fridge with water inside it. So how do you get the water out of it?
You get someone on the moon to pour you a gin and tonic, Nigel.
Yeah. You spotted there are impurities in this water. It's not pure at all. Well, in this case, yes, there's a screw cap at the top, so I can just open that. Where's my camera gone there? And do that. And then you get the water out. Yeah.
You're going to have to drink that now.
Yeah. I can check how the gin's doing. So, okay. So, because we knew on the moon, those little glass beads don't actually have a screw cap to them. So to get them out, you've really got a choice of either grinding them up very small and trying to get the water out that way to smash the glass, or melting the glass so the water comes out as vapor. And both those things are actually quite labor intensive, they're energy intensive. You need a lot of energy to be able to do that. So although it swings and roundabouts, this water is in a better place to go set up your base, but it's difficult to get the water out of it. If you go to the poles, the bottom of Shackleton crater, then it's more difficult because it's dark and it's difficult to get to. But actually, if the water is ice, then all you need to do is to take a lump of your soil, which has got the ice mixed in with it, and basically microwave it. And the microwaves will make the ice just boil away and you condense it. It's like putting your lunch in your microwave, and you can open the door and you've got condensed water all over the inside. You think, I've got to wipe that away now. I don't know, maybe you don't. Maybe I'm going wrong with my microwave cooking. Anyway, so
Do you wipe the inside of your microwave when you finish cooking every time?
well, if there's water in there, because the water absorbs microwaves. So if you leave the water coating the inside of it, next time you put something in there, then the water, which is condensed on the microwave cooker, will absorb some of the microwaves and it won't go into your food.
Heaven forbid I have to put it in for an extra minute longer.
Well, anyway, that's my theory. I've never actually read that in my cookery books, but I'm a physicist by background. So anyway, that's a story about ice on the moon, and so maybe we will go and set up the first moon base, not actually near the pole, but actually in Clavius. Does that ring any bells with you?
Clavius?
Yeah. A lunar base in Clavius. Or Clavius, some people might call it Clavius.
You're testing me on sci-fi now a bit, aren't you?
I am a little bit, yeah. Famous film.
Unless it's Short Circuit.
No.
I don't do sci-fi.
It's not the most famous part of the film, actually, Vicky. The most famous part is probably a computer called HAL, which...
that one, yeah.
Yeah, that one, yeah. And it starts off, 2001, A Space Odyssey starts off with a monolith that's found actually in the lunar crater Tycho. But the lunar base, where it all begins, is actually in the crater Clavius. So I think it'd be rather fitting if that's where it would go to show what a prophet Arthur C. Clarke was if he actually even got the location of the first lunar base absolutely right.
Could there be any chance of life there with this water?
I must admit, I would say no to that. Now, I know you've interviewed me before when I've been an optimist. I've said, yes, there's life on Mars, and said, yes, there's life on the clouds of Venus. But even I would find it very hard to believe that there could be life on the moon. I mean, I suppose if the water is inside these glass beads, then maybe the life could be. But remember, you still have the huge temperature swing from day to night. So during the day, the water reaches above the boiling point of water, although it's super squeezed, so it doesn't actually burst out of the glass, and at night it freezes solid. So I wouldn't be too hopeful, but maybe stranger things have happened.
Okay, Nigel. Well, the verdict is in on my limited edition chocolate twirl.
Mm-hmm. You're looking at very important matters. You're absolutely right.
Yeah, some people have been buying these by the box, and I'm going to say I'm glad I didn't, because it's quite hard going. That's all I'll say. Can you see it's quite pale chocolate?
Yes.
It's quite milky and rich and sweet. And I've eaten a whole Terry's chocolate orange this weekend, so I know my orange chocolate.
Yeah, as you see, but those are dark, and yes.
Yeah, it's all right. It's okay. It's all right if you want to. Oh, look, it's already melting. Nigel, thanks for that. So what do they think the next stage is for moon missions? Will this alter where they land, do you think?
I don't know. The plans are already quite well advanced, and nobody is yet saying whether it will or it won't. As I say, one of the problems is you have to devise a whole new technology. So far, people have been looking at how to get ice out of moon rocks in cold craters. Nobody's thought about getting water out of glass beads so far. So that's new technology. But I mean, NASA's plans to go back to the moon, I mean, amazingly, only 4 years away. 2024, the Artemis mission plans to land on the moon. And as NASA says, it's going to land the first woman and the next man on the moon. So it's going to be like space twins. So they've already picked already sort of picked a large selection of astronauts, and 2 of those people will be the ones who will actually go. But you might ask me, you might not, I mean, how are they going to get there?
How are we going to get there, Nigel?
Good question, Vicky.
Thank you.
Well, the answer is they're going to go on a rocket which hasn't even been tested or launched yet. NASA's Space Launch System. It's good zappy name, that, isn't it?
The Space Launch System is taking the air.
The SLS. We know the Space Shuttle. We all call it the Space Shuttle. NASA called it the STS, the Space Transportation System.
Hopefully they come up with a more snappy name for it.
And so other people come up with names like New Shepard or Falcon or Starship, some of the commercial ones, or Unity, which is my own Starship, which I'll be going up on. But anyway, so the Space Launch System actually hasn't been launched yet. It's like a giant Saturn V rocket. There's nothing particularly new about it. It's just like Saturn V and steroids. And the space capsule, which the astronauts will travel in, is, again, it's called Orion. So that's a bit snappier. We can remember that one. But that's just like a larger size of the Apollo capsule. So to me, it's really sad that having gone into a lot of technological amazing achievements at the space shuttle, but NASA's now gone back just to expand. And this is an expendable rocket. So you've got people like Elon Musk with his Falcon, and we've seen those amazing shots. It launches, it goes up into space, and then it comes down and it lands again, and they refurbish and they reuse it. The Space Launch System, they're going to throw it away, just like the old Saturn V is going to drop into the ocean, and only the capsule will come back to Earth again. So it's a bit, but anyway, that's a mission. The Space Launch System should take off on its first test unmanned in a year from now, and then there'll be a manned mission, a crewed mission, I should say. I must get away from manned, because to show how far back I go. Astronauts are obviously both genders now. So the first mission first launch a year from now, 3 years from now, first launch with a crew, which will go around the moon and back again, and then 2024 we'll land on the moon. That's the plan.
Wow! Thank you for that. I'm very excited for this, Nigel. Right, we're just going to figure out. I've got a slight feedback issue there. I've got something to ask you, Nigel.
Sure.
Do you know what the shortest measurement of time so far is?
Well, I'm trying to think what the small units of are. Like an atto is a 10 to the minus something of a second. But if you're trying to ask me what the smallest, well, I'm not sure the actual measurement. I don't have that off the top of my head. So please inform me.
Well, the time it takes a light particle to cross a hydrogen molecule is called. Do you know what it's called?
I don't know.
It's a great new word for us all. Where's the magic word gone on my article? A zeptosecond.
Zeptosecond. I like it. So that is actually shorter than an attosecond. So, well, fantastic.
This is, oh God, a zeptosecond is a trillionth of a billionth of a second.
Wow.
And that is a decimal point followed by 20 zeros and a 1. Previously, researchers had dipped into the realm of zeptoseconds. In 2016, physicists used lasers to measure time in increments down to 850 zeptoseconds. This new accuracy is a huge leap from the 1999 Nobel Prize-winning work that first measured time in femtoseconds, which are a millionth of a billionth of a second. Okay, it takes femtoseconds for chemical bonds to break and form, but it takes zeptoseconds, and 247 of them at that, for light to travel across a single hydrogen molecule.
Wow.
That's quite impressive, isn't it?
Yes, yeah, blink and you'd miss it.
Yeah, no falling asleep on that job. So what's happened is the researchers set the energy of the X-rays so that a single photon or particle of light knocked out the 2 electrons of a hydrogen molecule. The photon bounced 1 electron out of the molecule and then the other, a bit like a pebble skipping over a pond. These interactions created a wave pattern called an interference pattern. And this was measured with a tool called cold target recoil, ion momentum spectroscopy, or COLTRIMS, in a reaction microscope. So there you go. It's essentially a very sensitive particle detector that can record extremely fast atomic and molecular reactions. So there you go. That's amazing.
Okay, that'd be very useful to know. It could be useful in Scrabble as well, maybe, starting with a Z like that.
So we're getting down to a Planck time. What's a Planck time?
The Planck time is the shortest time that's possible to have at all. So not just, thanks for that question, Ian. It's not just the shortest you can measure, but the shortest that can theoretically exist. And it's 10 to the minus 43 of a second. So that is, you talk about decimal points, that's 43 figures after the 43 zeros after the decimal point. And nothing can, just because of the laws of quantum physics, nothing can actually be measured at all. And if I want to get shorter than a Planck time itself doesn't exist, because time goes in steps of Planck times. So if you think about a clock ticking every second, I mean, if something happens between the tick of a clock, I mean, I can hear my grandfather clock ticking, and I can get at least 2 or 3 words spoken to you between those ticks. But when you get to the Planck time, those are the individual steps of time. Nothing can happen in between.
I've always wondered, like, how many times can you devise time down to? Because if you've always got some time, can you keep on devising?
Well, thanks to Ian, we know you now it's down to the Planck time. And it's interesting, if you go back to the origin of the universe, the Big Bang, at time equals 0. We can't actually talk about a time equals 0. And we can only, as physicists, go back to 1 Planck time after the Big Bang actually happened, because it's meaningless to go back any further than that.
Oh, wow. I did not know that. And I've often wondered, like, what is the shortest? So a Planck, 1 Planck is the minimum time. A Planck time.
Absolutely. And after that, you get to 2 short planks.
I'm sure, yeah, all those jokes. Right, okay. Here's a great question from MJ8988. What's the quickest way to prove to someone the Earth isn't flat, other than throw them out of some kind of very high altitude?
I really don't know. I'm sorry, I can't really help you on that. I mean, to me, it's so daft that anybody could think the Earth is flat. I mean, the quickest way is to show them a picture taken from space. We'd have a picture taken by the Apollo astronaut showing the Earth, or when Elon Musk launched his Roadster car to the orbit of Mars a couple of years ago. He actually took pictures. So he wasn't a NASA employee. I mean, he was his own space tycoon, taking pictures of the Earth from space. So there are plenty of pictures. So either those pictures are right, and that shows the Earth isn't flat, or everybody, not just NASA, but all these other private entrepreneurs, are some big conspiracy.
or you can, because I live right by the sea, and you can definitely see the horizon a little bit at each side.
Mm-hmm. Yeah, when the ships go over the horizon, the hulls disappear first, and you only see the masts. That's what I was always told when I was young, because the ships actually go down below the horizon.
Yeah, okay. Go to your nearest seaside, watch a ship go down along the horizon.
I just hope it's not sinking. Exactly, I would confuse it.
Help! You can also look at the sun and see that is very round. And why would there suddenly be flatness in space when you can see that the sun is round?
Well, the way the ancient Greeks, about 500 BC, decided that the Earth was round, if not just round, but actually a sphere, was from eclipses of the moon, because they worked out that a lunar eclipse happens when the Earth's shadow falls onto the moon. And if you look at a lunar eclipse, the edge of the Earth's shadow is round. So that just goes to prove the Earth must be round.
Well, thank you, Nigel. The sky by eye. Hello, sky by eye. Tell them to keep walking in that direction and see what happens. It will also get rid of the questionnaire. Bye-bye.
Yeah, but sky by eye, sure, that would only happen if the Earth is actually flat, because then they keep walking and you never see them again. But if the Earth is round,
they're going to come back.
They'll actually walk all the way around, and before you know it, they'll be coming up behind you and tapping you on the shoulder and saying, "Okay, you were right. I've walked all the way around."
Especially if you were on one of the smaller moons or asteroids, which are kind of only just like at the limit, like 600 miles across or whatever it is, to before gravity contracts. Before. I'm not very good at explaining stuff. Circle, walk round, tap on shoulder. Again, hello, round.
Okay, yeah. That's a good way to do it. Walk all the way around the Earth. It might take you a bit of, I won't say that's the quickest way to prove it, if you're going to walk around the Earth, but it can be done.
What's the smallest, like some of these very small bodies that have only just managed to reach roundness by holding themselves together with gravity. And I can't remember what the minimum amount is now. It's a few hundred miles across before things coalesce into a sphere, isn't it?
It is, yeah. I mean, so it depends how hard the material is. So it's around about 500 kilometers, most people would say.
Just blow bubbles. Look at bubbles. There you go. Blow bubbles.
Well, that's absolutely right. Yep. So the Earth is a bubble. they're not quite, but never mind. we all live in our bubbles these days, so we've got some idea.
Oh, yeah. Who's it? Are we allowed bubbles? We're not allowed bubbles on Anglesey anymore.
No, I'm afraid all the bubbles have gone out of Wales.
My bubbles have completely burst, which is why I'm doing this. I'm attempting to create an Astro bubble. So step into my bubble, popular astronomer. Okay, so Nigel, there's something bright, red and beautiful in the sky at the minute. What is it that bright star? I mean, I know what it is. That's a rhetorical question.
I could say maybe it might be an orange chocolate bar for all I know. So,
yeah, sure.
It's tossed into the air. What you're looking at is Mars. Mars, the planet of war. Bright, well, not actually bright red. You know, I mean, everyone will know who looks at it. It's not like a traffic light red, but it's a color of blood red, and it's been associated with war, not just by the Romans. Mars is a Greek name. The Greeks called it Ares. That's our god of war, and going back to the Babylonians, so that's going back to 1 or 2000 BC. He was Nurgle. I like that. Nurgle, the planet of war.
Nurgle? That's much better than Mars. I'd much rather have a Nurgle bar than a Mars bar.
Yeah, I could almost think it's named after me, actually. So, look up there, you can see a Nurgle. But yeah, so anyway, this month, Mars has come its closest to the Earth for 2 years, and that's why it's been bright in the sky. Mars goes around the Earth in an oval-shaped orbit, when all the planets do, but Mars is a bit more oval than the others. It's not quite as circular. So when it's closest to the Earth, the distance can be quite different on different what we call oppositions. And just by one of those unlucky things for us, that when Mars is actually at its closest every few years, it's actually way down in the southern part of the sky. So if you're looking at it, you're looking through a thickness of our atmosphere from the northern hemisphere. Even through a telescope, everything looks wobbly because the atmosphere wobbles your image. But now it's climbing higher in the sky. So what's great this year is that it's still quite close to us, not its closest approach. Sorry, its closest approach for 2 years, but not its closest approach ever. But it is quite high in the sky, which is why we've been seeing it so well. So it is absolutely fantastic that we can go out and see it with the naked eye. Binoculars don't show you a lot more because it's quite a tiny planet, but telescopes show the dark markings on its surface and the polar cap. If you've got a good telescope, maybe some cloudy features, or when the wind blows up the dust, you can get a dust storm, which obliterates the features on the surface. So there's a lot to see and a lot going on Mars. And of course, we've got probes on the surface. We've got the Curiosity rover, which is going around looking for, looking at the past history of Mars. It's not actually looking for living beings or living cells even on Mars, but it's looking for the past history of Mars, and several orbiters going around making measurements from space as well. So Mars is right up there in the news. And we now have a new fleet of missions going there. 3, one is Chinese, one is from the United Arab Emirates, and then NASA's next rover called Perseverance. And what Perseverance will do when it gets there next year, it's going to trundle around. It looks very much like Curiosity, same kind of beast. But what it's going to do is to find rocks that look interesting, as if there might have been life there in the past. So life is associated with water. In the middle of a desert isn't a good place to look for life, but if you've got a nice warm spring, then it is. So if we find some rocks that look as if they were deposited in warm springs in the past, then the Perseverance will get a whole load of samples and take them back to its base. It's a bigger one. It's going to cache them where it finds them. Let's get this right. And then in a few years' time, another rover will go along and it's going to pick up those samples, put them on a rocket and send them back to the Earth. So the samples which Perseverance gets starting next year will eventually come back to Earth, and we can examine them in our labs here, looking in minute detail to see if there's any signs of maybe life in the past, or even micro fossils of bacterial cells. We don't expect big fossils in there. So it's an exciting time for Mars.
Go Mars. Yeah. I've got to confess, I haven't looked at it with my new telescope that I've got at the minute, and I really should make an effort to try and glimpse it in between the clouds. Have you done any stargazing recently, Nigel?
Not a lot. I mean, I've got. I mean, as an astronomer, I shouldn't actually live in this house. I ought to sell up and move on immediately, because there's a whole row of very tall trees to the south, and the south is where you've got the ecliptic, the band of the zodiac going across the sky, and that's where the moon and the planets are going to be. So from my back garden, I actually can't see anything. So I have to go out of my driveway or take telescope out onto the road. I get really good views from the road, but that's not always the best place to be at night. Or even during the day, actually looking at the sky. So I'm not a very active observer. I go out looking for meteors, constellation spotting, but I won't say that I'm the most serious observer that there ever has been.
Oh, Nigel, you absolute fraud.
I know I am. There you are. And now you have it from the horse's mouth.
Well, I know that there are some I know Robin Scadgel of the SPA, who edits our wonderful magazine that's out every 2 months. He puts, they've sent mine to my old address. So
would you want a quick flick through? I can show you.
Please, Nigel, could just give us a little quick flick through and I'll put it. This arrives on your doorstep every 2 months if you are a member of the SPA. So you can go solo layout. Here we go.
Yeah. So, okay. So this one arrived just a couple of days ago and it comes out 6 times a year. So this is the November-December edition arriving in good time. So there's Robin.
There's our Robin. He edits the magazine.
Yeah, and then you've got news stories. So this is the story about phosphine being discovered on Venus, and then lots more. And then Alice, who's a good friend of our society, does something. Alice Shepherd on citizen science. In other words, what you can do helping the professional astronomers from home. And then what telescope to get? So Ian Morrison.
Oh, lovely, Ian. Oh, I because he's part of Mac Astro. Sorry, there's a point to this creature here. I'll tell you about him in a minute. He got left behind.
I'm looking forward to the official introduction.
Oh, he's very nice. He's very friendly. Yeah, Ian Morrison. I'm definitely thinking of the same Ian Morrison. Yeah, he's a member of Mac Astro, and we went away on astronomy field trips to Anglesey every 2 months before lockdown. So I would see him almost as much as anybody in my life. So I'm missing. Ian Morrison has got the loveliest hugs.
Let's say hi, Ian.
We love you, Ian. We miss you.
Well, Vicky, I first met Ian as a radio astronomer because I did radio astronomy in Cambridge back in the old days. And Ian was at. You're absolutely right. Ian Croft was coming and saying excellent edition, and it absolutely is. Ian Morrison, he was a radio astronomer, and then of course he ended up as president of the SPA, and now we know each other through this. But he does a good column on what telescopes, things to get, and then around the amateur societies with Peter Wade, and then articles. So Mary McIntyre, good friend of ours too.
Amazing. Let's have a closer look at Mary's Moona crater. Oh yeah, look at that.
So as well as doing all the other astronomy things that she does, Mary is actually an amazing artist, and she's sketched all these lunar features. And here, she's letting you in on her trade secrets. Let's try to get this without the reflection. Look at that. Doesn't that look like a photograph? Lunar X, yeah. And then the SPA shop, so you know where to get your Christmas presents from. And then other articles. We have one on astrophotography. And then some sort of more mainstream articles about Mars. Is there life on Mars? And then a young stargazer. So Lucy Green has a column every issue for people who are starting out called Youngsters. But she's the chief stargazer. She's chief stargazer for the Society for Popular Astronomy. She tells you what you can do, and that's usually a practical thing. So I was talking about the rover on Mars. So this is Perseverance. So you can make your own Mars rover. She tells you what you need, what you will need, and then I won't talk it through in detail. You can cut it out.
Wow, that's really good, actually. So that's a great little make and do. And you got an interview with Tim Peake as well there.
Yeah, I can say there's always stuff about space travel, as well as astronomy. So an interview with our astronaut Tim Peake, and then all the news about space exploration. Look, SLS and Orion on track for November 2021 launch, just as I predicted when I spoke to you a few moments ago.
And Nigel, isn't there something in there about a book review?
I'm going to take a look at that. 20 years into, it's something we didn't mention yet, Vicky. I'll come back into what you're saying in a moment. But next week, I've had a week today, the International Space Station will have been permanently crewed for 20 years. 20 years ago, next on the 2nd of November. So it's year 2000. people first went up to the International Space Station. There's always been people, not the same people. 20 years in space will be a long time, but when one comes down, another one goes up. So it's absolutely amazing. So what's up in the sky? We've been talking about what to see in the sky, and that's a good roundup here by our friend Robin. Section reports. So members who send in reports of comets or aurorae or deep sky objects, photographs in the planets. You see how much there is in here. I'm amazed going through the magazine. Oh, there's a book review.
Right, I'll allow me. So a couple of months ago, I got asked to review your book, Nigel, before we kind of got associated with each other, and also which is the other one? Sorry.
It's the Collins Guide to the Night Sky. It's called, theirs is called the 2021 Guide to the Night Sky, and mine is called 2021 Stargazing.
And I have got to confess, I've never purchased these. I've always won them at raffles.
Congratulations!
I've always made sure that they are like because you buy 30 tickets and I run for the prize.
It costs you more. If you buy that number of tickets, it'd be cheaper to buy the books.
I'm famous for winning my books in raffles, and as a result, I've always got one of those in my glove box. And it is amazing how few astronomers actually have those reference books, and the amount of times I have trumped all the astronomers at meetings and when we go, meetings and getting out for impromptu sessions. It's me who's got the book in my glove box and can point everybody to what's happening in the sky, because often we just go out and go, well, what's out there? I don't really know. Especially with your book, Nigel, which is really beautifully illustrated and, of course, written with Heather, which makes it even more poignant. It's just such an essential astronomy item.
Thank you very much. Well, I'm going to say thank you very much for your lovely review, which you've done. If I get this magazine, now what does Vicky say? You're very much in the dark without this illuminating superstar of a guide. So thank you very much.
Thank you very much. And also, because I got both of the books at the same time, yours has got more colour plates in it than the Collins one. And I noticed that they both actually smell differently, and yours smells sweeter. And I deduced that must be the red ink in it.
I don't know. I passed on your very kind comments to my publisher and to my editor, and she's actually passed that particular comment on to the production department, because they're the ones responsible for choosing the ink.
More fragrant ink. So the Sky by Eye, recommend the Phillips book each year to my night classes. And of course, Nigel and the lovely Heather wrote that book. So please do support, please purchase.
Thank you very much, Sky by Eye.
Yeah, thank you so much. So Nigel, I think the best thing on your CV at the minute is the fact that you're a future astronaut. It's a great selling point. Tell us a little bit more about your potential voyages in space. And if you're a good boy, I will introduce you to this.
Okay, right. I shall do my very best.
Go on.
Okay, well, it's all thanks to a guy called Richard Branson, who decided back in 2004 to set up a space company, which he called, not surprisingly, the first part of the name is Virgin, because so many things to do with Richard R. But so the second part, we might call it Virgin Space Lines or something like that. But after the Virgin Atlantic airline, he called it Virgin Galactic. So it's not just about going into space or going to the moon, it's intergalactic. I don't expect to get quite that far, but it was a fantastic name. So the background is that back in 2004, a guy called Burt Rutan was the first private individual to build his own spaceship, fly it into space and down again, and fly it again within 2 weeks, the same spaceship. And up to space and down again. And Richard saw this and thought, that's a great idea. I wonder if I could actually, develop this to get up into space myself. Because Richard could actually afford to buy a ticket to go up to the International Space Station. Millionaires, billionaires do that all the time. But Richard being Richard, like when he took his hot air balloons across the Atlantic and the Pacific, he wants to do things differently and do it his way. So he followed up the original plan for Burt Rutan's spaceship, and it's developed into a spaceship which has got 2 pilots, or pilot and co-pilot if you like, and 6 passengers. And we'll go up into space, not into orbit, but just up into space, a short hop, a bit like, if you remember the early 1960s, the early astronauts like Alan Shepard didn't go into an orbit. They just went up and then came down again, and that's what we will do. And this isn't a big, powerful rocket. It's actually a little aeroplane, a space plane with a rocket engine in it. And there's a carrier plane called the mothership, which takes us up to 50,000 feet, which is quite a bit higher than your normal holiday flight would be, not quite as high as Concorde. But it takes us up to that high, 50,000 feet or 16,000 meters, and then releases the space plane. So we've got some advantage of getting a bit of height to begin with. We're not taking off from the ground. And it lights his rocket engine and it just goes like that. And I'm only going to quote some old-fashioned units here, so I'm sure a lot of people won't understand when I say we go from 30,000, but it's nice. It's nice round figures. We go from 50,000 feet to 350,000 feet in 90 seconds.
Figure that out, Nigel. Is it vertical?
It's vertical, yeah. We go vertically upwards. And then they cut off the rocket engine. And then, so I'll do it in my hand. I'll do it in slow motion. So we go up like that, cut off the rocket engine, and we just go up. And like a ball thrown in the air, we come down and then back into the atmosphere. And then the little wings will obviously catch the atmosphere and the plane levels out and we come down and we glide land, like the space shuttle used to do. So that's what the space adventure is. There's 700 people have now signed up for it. I signed up in 2009. I'm astronaut 245 in the queue. So
that's worse than being at the doctor's waiting room and there's like 10 people ahead of you.
Well, there's 6 people on the flight. So imagine in the doctor's waiting room, there's 200 people, but 6 patients are going in at a time. So it's a bit quicker than that.
Oh my gosh, Nigel. So how long's the best bit?
It's only a few minutes. I mean, I'd love it if it was longer, but given the operational performances and it's not a cheap ticket, but more than that would be a lot more expensive. So a few minutes. We don't know yet because we've had 2 flights into space. The first one just with the test pilots, and then the other one we had was with our chief astronaut trainer was actually in the passenger compartment. It hadn't been fitted up, so she was there sort of on a rackety old seat in the back, trying to see what best experience would be for us. But there's going to be another launch into space very soon. Again, like all these things in space, you can't put an exact date on it, particularly with COVID. But it will be quite soon. There's going to be another space flight to test the systems even further. And I hope, and my fingers are crossed, that next year our first passenger will go into space because all the systems are now in place. Passenger number one will be Sir Richard Branson himself. So he's going to go up there, pioneer the way into space. I mean, show that he wants to be the first there to pioneer and show us the way.
Wow, Nigel, I've got to confess, I didn't really know very much about it, and that's everything about that is surprising and amazing and exciting.
And there's a lot of information jammed in there, so please do ask other questions or anything which I haven't.
Yeah, what about in-flight snacks? That's the important thing.
The trolley dolly coming along and serving out. I probably can't say that anymore, can I? It's probably not politically correct.
Only if her name is Dolly.
I thought she was a sheep, but anyway, that's another.
Oh, wow, God, you're getting...
I'm sorry, I'm talking to somebody who lives in Wales. I instantly stopped talking about this. The good thing about the flight is that there are 6 of us, and there are 3 seats on either side, and an aisle down the middle. So we all have a window seat. And they've just released the design of what the inside of the spacecraft will be like. So we each have a really big porthole window to look out of, which is our own. And they've got a sort of rim around the edge, because remember, you're floating in weightlessness. You might want to take a look out, and you float away or somebody bumps into you, but you can hold on to this rim so you can take a look out. But the great thing is about this is that when we get up there, we unstrap from our seats. So it's not just a few minutes in space, it's a few minutes of actually floating around, being totally weightless. So we won't just be looking through our own windows, there are windows in the ceiling as well. So we'll float around, we'll look out in all directions, we'll see the Earth underneath. What our chief astronaut trainer said when she went up there, Beth Moses, said she just, she didn't even have the words to describe it, how beautiful the Earth was, how bright the Earth was. The sky was so black, the Earth was so bright, and then this very thin line of atmosphere. And so many astronauts say that. You just realize that just thin cloak of gas over the Earth is what actually protects us from space. But the sheer beauty of it is what really comes home.
So, like, how far away is the Earth going to be? Is it still going to fill the window, isn't it?
Yes, so it will. Yes, it's not going to be like going to the moon and getting
You're not going to get overview effect, are you?
No, not the total overview. No, I mean we're going to be launching from the middle of the United States, from New Mexico. So we'll mainly see the continent, and we may be able to see the Pacific Ocean off to one side. I haven't actually worked out the exact sight lines we're going to have, but we will see that the Earth is curved. So coming back to a previous question, if you've got
a ticket for Virgin Galactic, duh.
Yeah, I missed a sales opportunity there. I'm sorry, Sir Richard. I should have said that immediately, shouldn't I?
You can be an affiliate for Virgin Galactic for flight services.
Absolutely. So,
Wow, Nigel, God, there's so many. And then, other than in-flight snacks, will you get a refund if it doesn't go ahead?
Yes. If it doesn't go ahead, we get a 100% refund. And it's under, well, I don't want to get too much into business and politics. When I signed up for it, I thought it was absolutely rock solid. We'd get our money back because it's underwritten by Virgin Atlantic Airlines. But maybe. So yes, I hope I will get my money back if it doesn't all go ahead. But I mean, no, we will hope that it will. We had, the biggest setback we had was about 5 years ago, 6 years ago now, when we had that tragic accident.
Very well.
Yeah, when one of the pilots was actually killed, and the other's really lucky because he ejected and his parachute opened automatically and he landed and he survived it. And then Richard really looked very seriously at it, and if it had been a problem with the design of the spaceship, he would have pulled out then and given us all a refund. But it turned out it was pilot error. Tragically, the pilot pulled the lever at the wrong time. The co-pilot, I should say. I mean, they're both pilots. Co-pilot pulled a lever at the wrong time, and that's what caused the spaceship to break up. Now, clearly, that system has been redesigned, so nobody can ever again pull that particular lever at that particular time. And obviously, a lot of other safety features have now gone into it. But I say, having come through there, and we had a few hundred astronauts signed up at that time. I think it was about 600, and only about 20 or 30 pulled out. I mean, once we knew what the problem was and the fact it was soluble, most astronauts actually stuck with the program, and then we've gone from strength to strength since then. So the spaceship which is currently flying is our second one, and there are two more. I was out in California a year or two ago, and actually the two more which are being built and coming on stream. So that's be a fleet of 3, and then be another one following on. So the idea is to have 4. Originally it's going to be 5, but we lost one, obviously. 4 spaceships, and not just flying from America. I mean, clearly, the more we have flying, the quicker you can turn them around again, and then the faster we'll all move up the queue, which is good. But they don't necessarily all be out in New Mexico. The Italians are very interested in having Virgin Galactic flying from Italian soil, and there are discussions with the authorities in Cornwall to be flying Virgin Galactic from Newquay Airport. So the Cornish Enterprise Board is really keen on this, and the local authorities, local councils are all very keen on this. There are a lot of things involved in it. Clearly, British government needs to get involved, and so on. But we may, in a few years' time, be possible to go up into space. And the other thing I should say is, if you can wait a few years, and I'm eager to get up there as soon as I can. But if you're happy to hang around, if you think about it. How many people want to go up into space and particularly pay quite a lot of money for it? There's probably only a limited number of them. So if we wait a few years, maybe 5 years, certainly 10 years, they're going to be empty seats on the flights.
You'll be able to go up into space on your iPhone soon, the way technology's evolving.
That's right. But I just think that even with the technology we've got, I mean, if you're an entrepreneur and you've got an airline or a space line and you've got empty seats, what do? You drop the price of the ticket.
Oh, easy space.
That's right. Yeah. Okay. Register that name immediately, Vicky. Easy Space. We'll do that.
We'll be going to the moon like they're going to Benidorm soon.
Well, that's I mean, there are private entrepreneurs who are talking about space hotels. there is a module attached to the space station at the moment, built by Bigelow Aerospace, and Bigelow actually made his money in hotels in America. And his idea, the idea is, if you want to launch a hotel into space, a hotel is a big thing, so you need a big rocket. But actually, when you think about it, most of a hotel is empty space. It's like this room I'm sitting in. Most of it's empty space. You've just got walls around the edge. So his space hotel is made of inflatable modules. So you pack it in really small into your rocket. And when you get up in space, of course, when you put the air in it, in the vacuum of space, it'll expand like a balloon. So he's going to, and he actually has a couple of prototype small hotels up there, not designed that anyone will actually visit them, but just to prove the concept, which are free floating, quite apart from the module on the space station. So he's talking to people like Elon Musk, who's got the rocket. I mean, if Bigelow's got the modules, the hotel, and Elon Musk has got the rockets, then you could actually buy a ticket to go up and have a honeymoon in space, a holiday in space. Yeah. So it's I mean, all these things are happening. Maybe not tomorrow, but they are happening.
If we can rewind back to this broadcast and mute you out of it and just watch the expressions on my face. My eyebrows have really got to work out. You can tell I don't have Botox. Look at that. I've learned so much stuff there, Nigel, that I did not have a clue about. So thank you so much for explaining all that. I mean, there's so much good stuff, isn't there?
Yeah, there is. Well, as you know, I love talking about it. I think that's why you invited me on. So this stuff excites me just as much when I was a kid, and the space race was on, and the moon landing. It's all this stuff excites me to this day.
Wow. Okay, Nigel. Before we go, because it's coming up to Vicky needs to go home time. Because do you know I broadcast from a laundrette?
Your beautiful laundrette. Yes, I did know that actually. Yes. Ooh, now you're proving it.
Yeah, there's some nice bedding here. I can fix you up with a king size sheet if you want one.
Well, I can see you a nice bed. You don't even need to go home. You could just doss down there.
That would be amazing. Yeah. So currently I am in some holiday cottages, in the laundrette of some holiday cottages where I can find some decent internet, and I'm very kindly allowed to use this space. But Anglesey and the rest of Wales is in real proper full lockdown now. And it's so this is what we're going to be doing. Whenever I can get down here to these little this little laundrette, and whenever there is an astronomer available to chat to, Nigel, I hope we can call on you multiple times, because let's face it, our diaries are not full at the minute, are they?
They're flexible, shall we say? Absolutely. No, I'd love to come on again. Thank you very much for having me, Vicky.
It's an absolute pleasure, Nigel. Now, when I was here a couple of weeks ago, this was left on the table through there with a note saying left in cottage number 8.
Ah, poor little thing.
So I didn't steal it. I looked after it. My maternal instinct. Under my wing, and now he just sits in my bag, and he's been named Cosmo by one of the SPA people, and I can't remember who it was. And do you know what he does? He comes home and he hangs on my telescope.
Okay, well, there you go. No, he's going to help you take a look. I mean, if he's Cosmo, he knows what you should be looking at through that telescope.
Yes, he should actually. I'm sure I read something about sloths and space the other day. No, I'm getting confused now. I'm getting confused between articles. But yeah, this is Cosmo anyway, Nigel, and he sends all of his sloth-like regards.
Hello, Cosmo. Good to meet you. If he went up into space, you have a problem. We wouldn't be able to hang from his branch. It's confusing.
So, Nigel, tonight we have talked about potential water on the moon in glass beads. That is just weird. We've talked about Mars. We've talked about Virgin Galactic. We've sampled chocolate live on air. It's been quite an action-packed show. So if you would like to come back for more of this, I don't know when the next one will be. It might even be tomorrow. But for sure, join us for Pop Astro Live, which is the official flagship show, coming up this Friday at 8 o'clock, and I still need to arrange a load of guests for that. So let's get on with it.
Okay, it's been huge fun, Vicky. And it's great to have everyone who's come and joined us as well. Thank you for joining in.
Yeah, thank you for the comments, everybody. It's been lovely. Really nice way to just stay connected with other SPA members, because otherwise, what else is there? Just sitting on my sofa on Facebook. It's not good. I'll see you later. Bye.